In the unending silent dark between the stars, there are stories adrift on the solar wind. They are chronicles written in ice and rock, traveling for eons through a vacuum so profound it redefines the very concept of solitude. We have learned to read the faint whispers of these cosmic messengers as they fall toward our sun, briefly illuminated before they vanish once more. For centuries, we believed they were all our own wayward children of our solar system returning home. But the cosmos is vastly larger and more ancient than our ancestors could have ever conceived, and it has begun to send us missives from realms we once considered unreachable. First came the whispers, fleeting and strange. Now a new visitor has emerged from the deep, a ghostly wanderer on a path so bizarre, so alien, it challenges our fundamental understanding of our place in the galaxy and indeed the universe itself. It is an object on a trajectory of sheer impossibility, a traveller arriving from the wrong direction at the wrong angle at the wrong speed. Its designation is clinical, almost mundane, C. 2025 V1 Borisov. But its story is anything but. It is a tale that may not have begun in our galaxy at all. The story of its revelation began not with a thunderous roar, but with the quiet hum of electronics in the cold Crimean night. At the Margot Observatory, a small privately owned facility, an astronomer was conducting a routine sky survey. The name Gennady Borisov already echoed in these halls, a testament to the power of dedicated skywatchers. It was he who years earlier had gifted the world its first glimpse of a truly interstellar comet 2I, Borisov. This new search was a continuation of that grand legacy, a patient vigil kept against the infinite black. On a series of digital exposures taken in late autumn, a faint, almost imperceptible smudge appeared where none should be. This is the daily bread of comet hunters sifting through countless false positives, cosmic ray hits, and the faint ghosts of distant nebulae. The initial software flagged the anomaly, but assigned it a low probability. It was likely noise, a fleeting glitch in the sensitive CCD sensor. Yet something about its subtle motion over several frames pricked at the astronomer's intuition, a sixth sense honed by thousands of hours spent staring into the void. A request was sent out across the global network of professional and amateur observatories. This is the collaborative heart of modern astronomy, a chain of eyes linked by the internet, passing the baton of observation as the Earth relentlessly spins. In Chile, atop the desolate peaks of the Atacama, a larger telescope swiveled its colossal mirror towards the coordinates. The data that returned was sharper, clearer, and deeply unsettling. The smudge was real. It was a comet, its faint coma of vaporizing ice and dust, already beginning to glow as it felt the distant, nascent warmth of our sun. Then came the calculations, the mathematical ritual that transforms points of light into celestial journeys. Teams from the Minor Planet Center in the United States and astronomers across Europe began crunching the numbers. The first orbital solutions that spooled out of the computers were met with disbelief, then frantic cross-checking. There had to be an error in the data, a miscalculation. The numbers painted a picture of a path that defied logic. They suggested an orbit tilted at a shocking angle, a trajectory so steep it was almost perpendicular to the plane, where all the planets dutifully circle. The inclination was measured at 113 degrees. To understand the profound strangeness of this number, one must first visualize the architecture of our solar system. Imagine it as a vast spinning carousel, magnificent and orderly. In the center, the sun is the radiant, unmoving pillar. The planets, Earth, Mars, Jupiter, and all the others, are the painted horses, each in its own ring, all circling in the same direction on the same flat level floor. This shared plane of existence is called the ecliptic. It is the family resemblance of our solar system, the enduring signature of the swirling disk of gas and dust from which all our worlds were born 4.5 billion years ago. Most objects in our cosmic neighborhood play by these rules. Asteroids from the main belt orbit between Mars and Jupiter, their paths tilted by only a few degrees from the ecliptic floor. Even the comets from the Kuiper belt out past Neptune largely adhere to this cosmic traffic pattern. They are the distant, icy members of our celestial family. Then there is the Oort cloud, a theoretical immense sphere of trillions of comets, encasing the entire solar system like a ghostly shell. When a comet from this distant realm is nudged inward, It can arrive from any direction, from high above or deep below the carousel. These comets can have high inclinations, sometimes even appearing to travel backward against the flow of the planets. But they all share one critical characteristic: they are leashed. They are prisoners of the sun's gravity, bound in orbits that may take millions of years to complete, but they will eventually return. They are part of our system. They belong to us. C. 2025. V1 Borisov did not belong. The 113-degree inclination was just the beginning. An angle over 90 degrees means an object is in a retrograde orbit, moving against the majestic counterclockwise sweep of the planets. It was a salmon swimming against the current of the entire river. But it wasn't just its direction that was wrong. It was its velocity, its sheer unbridled speed. As astronomers refined its trajectory, they calculated not just where it was going, but where it had come from. The path was not a closed loop, not a vast, stretched-out ellipse, like the orbits of our own long-period comets. Its trajectory was a hyperbola, a perfect open-ended curve. To grasp the significance of this picture, a game of cosmic catch. The sun is the catcher, and its gravitational field is its glove. Any object born within our solar system, a comet from the Oort cloud for instance, is like a ball tossed gently into the air. No matter how high it goes, it eventually slows, stops and falls back down, caught securely in the sun's gravitational glove. Its journey is a closed loop, an ellipse. It is gravitationally bound. Now imagine a ball fired from a powerful cannon, a cannon located light years away in the interstellar darkness. This ball isn't just tossed, it is launched with ferocious speed. As it approaches our sun, gravity will bend its path, pulling it into a curve. But its velocity is too great. The sun's gravitational glove can't close around it. It will swing past the sun in a wide arc, and then, having barely acknowledged our star's existence, it will continue its journey, coasting back into the void, never to return. This open-ended path is a hyperbola. It is the unmistakable signature of an outsider. It is the calling card of an interstellar visitor. Humanity had been introduced to this startling concept only a few years prior. In 2017, a bizarre cigar-shaped object, later named Oumuamua, meaning scout in Hawaiian, tumbled through our solar system. It was small, dark, and moved in a way that defied easy explanation, accelerating slightly, as if from some unseen force. Its visit was fleeting, its nature still debated with passionate intensity. Was it a nitrogen iceberg, a new type of comet, or as some tantalizingly proposed, an alien artifact? Then in 2019, Gennady Borisov himself discovered 2I, Borisov. This second interstellar guest was more familiar. It looked and behaved like a comet, developing a beautiful coma and tail. Its composition was even analysed, revealing it was not so different from the comets born in our own celestial backyard. Oumuamua and 2I, Borisov, were a paradigm shift. They confirmed that the space between stars was not empty, but a cosmic ocean teeming with wandering objects, debris cast off from the formation of other solar systems. Our solar system was not an isolated island, but a port of call on an invisible interstellar shipping lane. But C 2025 V1 Borisov was different. Its speed was extreme even for an interstellar traveller. Its path was bewildering. When astronomers traced its hyperbolic trajectory backward out of our solar system and into the galactic neighbourhood, they encountered a profound and chilling puzzle. The path didn't point back towards any nearby star. It didn't originate from the direction of any known stellar nursery or any cluster of young chaotic stars known for ejecting material. Its trajectory was an arrow shot from the empty dark. As more data poured in, a radical, almost unthinkable hypothesis began to form. The teams plotting its origin vector noticed something astonishing. When they accounted for the motion of our own sun as it orbits the galactic center and then mapped the comet's incoming path against the backdrop of the Milky Way, the numbers didn't seem to fit. The velocity vector of C 2025 V1 Borisov was so high and its direction so peculiar that it was difficult to reconcile its origin with any plausible event within our own galaxy. An object ejected from another star system in the Milky Way would still share in the general stately rotation of the galactic disk. It would be like a piece of driftwood thrown from one boat to another in a vast, slowly swirling river. The driftwood may have its own motion, but it is still fundamentally carried along by the river's current. This new visitor, however, seemed to be moving without regard for our galaxy's current. It was a speedboat cutting across the river at a bizarre angle. The question, spoken at first in hushed tones in late-night video calls and on encrypted scientific forums, was terrifying in its implications. What if this object wasn't just interstellar? What if it wasn't from our river at all? What if it had crossed the ocean? Could this strange comet be intergalactic? The leap from interstellar to intergalactic is not a step. It is a fall into a chasm of scale so immense that the human mind struggles to contain it. To try and visualize it, let us construct another analogy. Imagine our entire solar system, out to the farthest reaches of the Oort cloud, is the size of a single comfortable house. On this scale, the nearest star, Proxima Centauri, is another house located 4 kilometers or about 2.5 miles away. The Milky Way galaxy, our home, is not a city or even a country. It is a sprawling continent-sized metropolis of 100 billion of these houses, separated by vast stretches of neighborhood, district, and suburban emptiness. An interstellar object like Oumuamua is a piece of mail that has blown from a house a few miles away and drifted past our own. A remarkable journey, to be sure, but the nearest major galaxy, Andromeda, is another continent-sized metropolis entirely, and it is separated from ours by an ocean of nothingness so vast it would take light, the fastest thing in existence, more than 2.5 million years to cross it. The space between galaxies is a void of unimaginable emptiness and antiquity. To suggest that C 2025 V1 Borisov had made that crossing was to propose a journey of such loneliness and duration that it bordered on the mythological. The scientific community, rightly conservative, demanded proof. The burden of evidence for such an extraordinary claim had to be absolute. The key lay in the comet's chemistry and its very substance. As C 2025 V1 plunged closer to the Sun, it began to warm dramatically. Ancient ices frozen for billions of years began to sublimate, turning directly from solid to gas erupting from its surface. This expanding cloud of material, its coma, was a spectral treasure trove. The world's most powerful telescopes from the ground and in space turned their gaze upon the visitor not just to see it, but to dissect the very light that passed through its ghostly atmosphere. This technique, called spectroscopy, is a form of cosmic alchemy. By splitting the light from the comet into its constituent rainbow of colors, astronomers can identify the chemical fingerprints of the elements and molecules present. Every element, whether it's hydrogen, oxygen, or carbon, absorbs and emits light at specific, unique wavelengths. These appear as dark or bright lines in the spectrum, a chemical barcode that tells us precisely what the object is made of. The first results for C 2025 V1 Borisov were at once familiar and deeply strange. Water was there as expected. Carbon monoxide, cyanogen, the typical building blocks of comets, were all present. It was fundamentally a dirty snowball just like our own. The initial wave of data seemed to undermine the fantastic intergalactic theory. Perhaps it was just a highly unusual comet from our own galaxy after all. But science thrives in the details, in the subtle deviations from the norm. The real answers lay not just in which elements were present, but in their specific flavors, their isotopes. Isotopes are versions of an element that have slightly different masses. For example, most oxygen in our solar system is oxygen 1,6, but there are trace amounts of heavier isotopes, oxygen 1,7 and oxygen 1,8. The precise ratio of these isotopes is a local signature, a product of the specific mix of materials present in the primordial nebula that formed our sun and planets. It's like a regional accent, a chemical dialect unique to our corner of the galaxy. Different star-forming regions elsewhere in the Milky Way would have slightly different isotopic ratios, reflecting their own unique histories of stellar birth and death. As the data on C 2025 V1's isotopes was painstakingly collected and analyzed, a startling picture began to emerge. The ratio of nitrogen isotopes, nitrogen 1,4 to nitrogen 1,5, was significantly different from any comet or asteroid ever measured in our solar system. It didn't match the isotopic signature of our local interstellar neighborhood either. The oxygen ratios were also anomalous, suggesting the water ice in this comet had formed in an environment with a fundamentally different chemical composition than the one that gave rise to our own existence. It was as if we were listening to a familiar language, but spoken with an accent so thick, so alien, it could only have developed in a place utterly separate from our own. This was the smoking gun. This was the proof. The combination of its impossible trajectory, its extreme velocity, and now its alien chemical dialect transformed the hypothesis from wild speculation into a near certainty. This small tumbling piece of ice and rock, no more than a few kilometers across, was an ambassador from another galaxy. It was a physical artifact from a place hundreds of thousands, perhaps millions of light years away. The mind reels trying to comprehend its odyssey. Where could it have come from? How was it launched with such force that it not only escaped its parent star, but its entire home galaxy? The scenarios are all cataclysmic, operating on a scale of cosmic violence. Perhaps billions of years ago, in a galaxy far away, two stars in a binary system collided and merged. Such an event would be a gravitational convulsion capable of flinging planets and comets out of the system at incredible speeds. Or maybe it was born in a star system that wandered too close to the supermassive black hole at the heart of its galaxy. The star would be torn apart by tidal forces, and its planetary children, including this comet, catapulted out into the intergalactic void like stones from a slingshot. A more poignant possibility is that it is a refugee, a relic from a small dwarf galaxy that was cannibalized, eaten alive by a larger galaxy like our Milky Way or Andromeda. As the dwarf galaxy was shredded by gravity, its stars and planetary systems were scattered, and this lonely comet was cast adrift, a homeless wanderer destined for an eternity of darkness. Whatever its origin, its journey is almost beyond imagining. For millions, maybe hundreds of millions of years, it sailed through the absolute zero of the intergalactic medium. It was a realm where the light from the nearest stars would be nothing more than a faint, hazy glow in the sky. It was bombarded by high-energy cosmic rays weathered by an eternity of silence and cold. It is a survivor, a testament to the resilience of matter, and now, by pure dumb luck, its path has intersected with ours. Out of the uncounted trillions of cubic light-years of empty space, this tiny emissary has found our doorstep. The implications of its arrival are profound, rippling out from astronomy into philosophy and our very sense of self. For the first time in human history, we are not just observing light from another galaxy, we are interacting with its physical substance. This is not a photograph of a foreign land, this is a grain of sand from its shore, delivered directly to our laboratory. By studying its makeup, we learn about the chemistry of star formation in a completely separate galactic ecosystem. It provides a single precious data point in a graph where previously we had none. It allows us to test whether the laws of physics and chemistry that govern our galaxy are truly universal. The questions it raises are as deep as the void it crossed. It forces us to confront the concept of panspermia, the theory that life itself can be seeded between worlds on a scale we had never dared to consider. The journey between stars is harsh enough for any potential microorganism hitching a ride on a comet. The radiation and timescales of an intergalactic journey would be exponentially more hostile. It seems fantastically unlikely that life could survive such a passage, and yet 2025 V1 Borisov proves that the vehicle for such a transfer exists. The raw materials, the water and carbon compounds can and do make the crossing. It suggests that the building blocks of life at the very least are not confined to their home galaxies, but are shared particle by particle across the unimaginable gulfs of the cosmos. As 2025 V1, Borisov makes its closest approach to our Sun, every instrument capable of observing it is working overtime. The opportunity is fleeting. Soon, its hyperbolic path will whip it around our star, using the Sun's gravity as a slingshot to propel it back into the darkness from which it came. It will recede, growing fainter and fainter, until it is once again just an imperceptible smudge, and then nothing at all. Its light will be gone, but its legacy will be permanent. It has redrawn the boundaries of our cosmic neighborhood. It has shown us that the great voids between the galaxies are not barriers but highways, and that traffic is flowing. We are left to wonder how many more are out there. For every one that happens to pass through the tiny sunlit courtyard of our inner solar system, how many millions more are sailing silently through the outer darkness, unseen and unknown? C. 2025. V1 Borisov is a wake-up call, challenge to build new telescopes, more powerful surveys designed specifically to hunt for these ghosts, to create a net with which to catch these messages in a bottle thrown from shores we will never see. Look up at the night sky, the familiar constellations, the steady light of the planets, the soft ethereal river of the Milky Way itself. It all feels like home. It all feels like our universe. But we now know it is an open system. We are part of a conversation we never knew was happening. And somewhere out in that silent, patient dark, another messenger is on its way. It has been traveling for 1,000,000 years or 1,000,000,000. It carries in its frozen heart the chemical secrets of its birth, a story of a sun and a system utterly alien to our own. And one day, it too may fall toward our light, offering us another sentence, another clue from the grand intergalactic story of everything. C. 2025 V1 Borisov was not an ending, it was the beginning of the search,